Hello, welcome to part 2 of the course, Which Paths for a Sustainable World? Part 1 covered problems, part 2 covers solutions. If you haven't seen the first part, I definitely encourage you to please do so. All the videos and all the corresponding materials are available on the Learning Planet website on the course page. And so now we are going to tackle this second part, the space of solutions, with essentially 3 main sections. The first part that provides an extremely quick overview of the significant major issues we are facing in order to set the scene and provide updates. A second part then is dedicated to the fundamental principle of effectively structuring the solution space. And finally, we will conclude with the chaptering of the upcoming courses. So to begin, I think it's appropriate to start again from the important planetary boundaries model. The planetary boundaries model is the model that was designed by the Rockstrom team in 2009 and has unfortunately evolved since then. You have the 9 limits, which are represented here: climate change, biodiversity, soil condition and water condition, biogeochemical flows, the nitrogen and phosphorus cycles, ocean acidification, atmospheric pollutants, stratospheric ozone, and this part, the new entities, meaning all chemical compounds. As we can clearly see on this model, we now have 3 limits that are very formally exceeded and have indeed entered an extremely dangerous zone. The first, historically the most important, is the collapse of biodiversity, at least in its genetic component. The second is the nitrogen cycle and the phosphorus cycle, which are now completely outside their limits. There is far too much nitrogen and phosphorus accumulating over time, especially in rivers, lakes and seas. And then there is a third limit that has also been formally exceeded, and this is a recent work that has just been published, showing that the chemical compounds accumulating particularly in the waters, land and atmosphere are now far too numerous and dangerous for the stability of the biosphere. So we have these 3 limits that are formally exceeded, which have entered a zone of proven danger. And then there are 2 others that have entered a danger zone and have surpassed the zone of uncertainty. The first is climate change. As we saw in the initial session, if we exceed 1.5 degrees Celsius, and especially 2 degrees Celsius, we approach tipping points that are extremely dangerous indeed. And then the Earth system, soil artificialization, its use for agriculture, and the fact that soil distribution between us and the biosphere has reached very concerning levels. So fundamentally, these are essentially the various different limits, their uses, and the challenges we are facing. In this slide, the 4 hours donut model is presented, which I also presented last time during our previous meeting. As a reminder, it is indeed a rather sophisticated, elegant and very visual way to see how to delineate the safe and just space for humanity, which allows for inclusive and sustainable economic development. What does that mean? It means that our economic activity, the economic activity of humanity, must be contained within the planetary boundaries we just mentioned, because beyond this ceiling, we reach a critical degradation of the environment. At the same time, we must ensure a number of essential services for humanity, which are listed here, representing the social floor. If we fall below this social floor, it results in significant and critical deprivation for the populations. So we must navigate between the social floor and the environmental ceiling. Given what we've just discussed, and again I encourage you to watch the previous videos, what needs to be done is to fundamentally transform the economic and industrial mechanics of humanity, its metabolism, to achieve several things in essence and ultimately. Here are represented, so this is the slide that comes from the panel on global resources. You have in red the GDP, which is the indicator of economic activity. In green, the well-being and prosperity of populations. in blue the natural and mineral resources that are necessary for this economic activity, and in green the environmental impacts. What we observe is that typically as GDP increases, we consequently draw more from resources and increase environmental impacts. The goal is to achieve this triple decoupling in the future, which means continuing to increase well-being without increasing economic activity under the same conditions. This decoupling is the decoupling of prosperity. The next part of the course will be on this section. And then there is also this necessity to decouple, using fewer resources to produce more services or more economic activities, and especially to have reduced environmental impacts called absolute decoupling, so that we can stay within the planetary boundaries. So these three decouplings, the decoupling of impacts, the decoupling of resources, and the decoupling of prosperity, are the three decouplings that we will need to successfully achieve in the next 30 to 40 years. This is the focus of the comprehensive chapters I will now present to you. To see where we stand on these issues, what possible solution paths exist, what is already in progress, what research presents, what public policies present, social innovation, entrepreneurs, and so on. There are a lot of people who have been working on these topics for many decades now in the field of sustainable development. If we refer to its birth in 1972, it has now been 50 years people, or at least a part of the population, has known about these issues. A lot of things have been done, some have worked, others have not. There are still many things left to do. And so, I now propose that we take a look at a comprehensive overview of everything that is possible. So, in small incremental steps, I do not claim to be exhaustive at all. We will look at a number of different elements, and to be able to properly and accurately characterize the possible solutions, what I would like to do now is to present to you the main guiding principles that have allowed me to map out this space of solutions. What are the principles on which I based myself to retain the elements that seem important to me for establishing this space of solutions? Well, there are fundamentally 5. First, the solutions must be systemic in nature and comprehensive, meaning they must take into account the entire space of problems. It's the best way to identify the right levers, because if we don't have a thorough and comprehensive understanding of all the various and different problems, there's a possibility of creating a solution or implementing a measure that will have potentially harmful or adverse effects on other different aspects of the problem. This is what I call an integrated approach. We need to be able to consider the positive and negative effects on other sustainable development goals, on other components of sustainability. And we can clearly see without a systemic vision, it is difficult to have an integrated approach. So for the scientific part, what is necessary is to have an interdisciplinary approach, meaning that all expertise is needed. We will see an example of this. It seems obvious, but in reality, it is extremely complicated to implement, and it is also a promising path for the future. The approaches must be complementary. Combining different approaches is better than one solution. Why? Because we have searched for single solutions for years and we haven't found any. Instead of 100%, if we have 5%, it's not much. If we have 20, it makes 100% if they are truly additive. So we see that by breaking the problem into smaller pieces and trying to find solutions adapted to smaller scales or lower levels, we eventually manage to reproduce a model that can be interesting. And then I will also explain in detail why it must be agnostic and thoroughly. These solutions must explore both sobriety, how we will reduce our consumption, material flows, energy flows, how we can influence cultural changes, how we can change our modes of organization, and how we can invent new technologies or new systems in various ways. It's not one or the other, it's the whole, especially because we are in a complementary approach, and it gets stronger if we act on multiple levers. So for the systemic approaches, I suggested putting the important Ignacy-Sachs figure on this slide first as a reference. Ignacy-Sachs is one of the founding fathers of sustainable development. He was a person who played a very important role in the 70s, especially in 72,
during the United Nations awareness of sustainability issues, and he is one of the founding fathers of what is called sustainable development. Sustainable development is a term now overused, but it is a translation of an English term that was sustainable development. These are the sources of sustainability, meaning the ability to have economic and social activities that do not exceed the planet's production and regeneration capacities. This concept really emerged about 50 years ago. Although it may be overused, I'm definitely including it here because it's truly an incredibly interesting visual for this systemic approach. It's an intriguingly interesting visual that adds a lot of value. For human development to be sustainable, it must respect the environment, preserve areas, the diversity of species, and conserve natural resources. We've seen this with the planetary boundaries. The economy must be able to create wealth and significantly improve material living conditions. And we have also seen in previous episodes how important this is, especially for developing countries. And then society must meet essential needs. This includes the elements mentioned by Kate Raworth. It's both and the other way around, because if 2 by 2 we have a decrease, an environmental collapse, a resource erosion, an economy that no longer works, or a society that is falling apart, in all cases we have very harsh crises that will worsen the phenomena, especially the environmental phenomena. For the integrated part specifically, I made use of this particular slide from Ambition Action, which lists all of the links and interdependencies between each one of these sustainable development goals. On the left, political measures that can be taken, for example, on electricity, heat, transportation, and buildings. And on the right, the corresponding sustainable development goals. And we see that a large part, if not all, of these actions will have other effects, meaning not just on the corresponding SDG, that is energy, but everything related to energy will also have impacts on poverty, hunger, the economic system, the way cities are organized, etc. So in a systemic approach, we must have integrated and interconnected systems to avoid having harmful effects in one area when making decisions in another. And conversely, we hope that this interdependence can indeed help identify areas where, when we do something in one field, it also significantly benefits another field. So typically, if we insulate buildings, even though it is expensive, it is much better for greenhouse gas emissions, but it is also much better for poverty, since many energy inefficient homes are inhabited by people who are in great need. So for the interdisciplinary dimension, it's always difficult to represent, but this is a paper that is now about 10 years old, which shows, it's a representation of the fields of research. So each little dot represents a scientific field. What does it illustrate? The fact that knowledge today is fragmented into hundreds, thousands, tens of thousands of fields or subfields with very, very diverse expertise. So the research activity is multifaceted, extremely rich and comprehensive, but it is also, as you can see, compartmentalized. For instance, individuals who have a keen interest in dermatology rarely collaborate with those professionals who specialize in polymers or mineralogy. So you might say, that's completely normal, I don't know. In any case, it's interesting to see on this graph both the complexity of the current human research system. Just to give you an idea, it's several million publications per year, and it increases every year.
So no one can know absolutely everything. No one can be all-knowing. This fragmentation of knowledge is exceptionally important, and it also leads to the fact that for a given problem, we can find in different disciplines pieces of knowledge and insights that are incredibly useful to mobilize in order to decipher a problem or provide an effective solution. So here I took the example of a paper that was published 2 years ago on carbon sequestration and on the interdisciplinary work around this subject. The work on carbon sequestration in Africa involves, given the complexity of the actors and disciplines at play, it will mobilize various scientific fields ranging from political science to geometry and geography, from anthropology to agronomy and pedology to soil science and so on. So we have a very wide diversity of scientific fields, all of which must interact and find ways of common expression in order to develop knowledge tools together and build frameworks, systems and solutions in which we can find integrated and comprehensive solutions to the problem at hand, collaboratively and effectively. The principle of complementarity is both simple and visually here we can see that it is not so simple. Indeed, since we have many problems, we have many different, various and diverse solutions. What does that mean? Here, that is to say, I have represented the various sources of greenhouse gas emissions from a course on climate, the link to which you will find in the description, which is quite exceptional. It was done by the Drawdown project. So here you have the representation of greenhouse gases. What do we see? We see that electricity production is about 25%, so that's a quarter. Another quarter comes from agriculture and land use.
We have a small quarter from industry and then a large part that covers everything else, including transportation, buildings and other sectors.
So we have a problem with at least 4 major components, but within these components we can go into more detail, and then there's even a vision where we go further. Electricity production is used in buildings, but also in industry, such as factories, etc. Deforestation is not the same thing as nitrous oxide from fertilizers or even the flatulence, well, rather the burps of cows. Indeed, deforestation is a different issue. Here we have a broad outline, and it is indeed clear that if we want to solve the problem of climate change, that is, to completely stop greenhouse gas emissions, or at least have the amount of greenhouse gases emitted equal to the amount absorbed, thus essentially achieving net zero, everything needs to be reduced, ultimately. So we need solutions for electricity, solutions for agriculture, solutions for industry, transportation, buildings, etc. This means that each time all of these points, which indeed account for between 1 and 10%, must find solutions that are both capable of drastically reducing these emissions, but also socially acceptable and financially viable. So in essence, the last fundamental principle is that the approaches must be agnostic. To illustrate this, I took these 2 books, which obviously are completely and utterly opposed.
The first one then, The Halt to Growth, the report from the Club of Rome in 1972 called The Limits to Growth, which was reviewed and updated a few years ago, demonstrates that the trajectories anticipated in the 70s are absolutely perfectly aligned with our current situation. The limits to growth. What does this report say? Overall, we are extracting so much from resources and accumulating so much pollution that the system is not sustainable. We must immediately systematically stop, reduce our consumption to the maximum, and change our production devices to reduce.
And so the most important factor in our daily lives is sobriety and moderation in consumption. The second book is by Peter Diamandis, who is a notable and influential figure in the field of Silicon Valley. He created the Singularity University in the United States, and he believes, on the contrary, that technological and scientific innovation will allow us to overcome all the various challenges and issues we are currently facing. Therefore, he predicts a future of abundance. So, on one hand, we have approaches that focus on being more economical and frugal, and on the other hand, an approach that is much more about innovation and inventing new ways of doing things. So this is what I have summarized in a very, very caricatured and schematic way. I am well aware of that, but it is to make it understandable. In one case, to be able to live better together, we need to do less and adopt greater sobriety. In another case, we may need to do as much or even more, but differently. And it's indeed technological innovation that will save us. So, to be always caricatural, on one side you have degrowth, and on the other you have green growth. Another way to present this is through a different value scheme, meaning the position we have on technology and what it will be capable of doing will indicate
a number of various solutions, or will guide the reflection on what kind of solutions are possible.
So if we start with less and sobriety, the first thing to do is obviously to reduce. We can reuse, we can optimize, we can recycle. And we see that all these words really fall into this important category. And then at the other end of the spectrum, we can substitute, transform, innovate, and rearrange in various ways. So one will tend to rely more heavily on cultural evolution, an evolution of demand, an evolution of consumption, and the other more on technical transformation, on a transformation of production. Again, of course, we definitely need both, and it is undoubtedly the integration of the two that will allow us to achieve and get closer to the objectives. What is indeed fascinating is to see that this type of model works not only for technological innovation, but also for the relationship with nature. In one case, you have, for example, deep ecology, which aims to preserve forests, oceans, and various ecosystems as much as possible. And then you have different intermediaries between conserving, protecting, restoring, and even developing new systems. And as we will see in other videos later, all of these verbs correspond to actions, to political actions, to implementations, and are currently underway. So, to explore this space of solutions, which is the second part of this course, I have mainly and primarily taken information from three major fields. The first are research articles. Research articles are not perfect, but they typically have an advantage. They are published and peer-reviewed in general. What does that mean? It means that each article that is published is reviewed by specialists in the field of study, and therefore, on average, there are fewer errors than if no one read them. This serves as the construction of a knowledge base. This allows us to see if knowledge evolves and things that were true at one point are less so, and it helps to evolve the foundation of common knowledge. Research articles represent an important point, but there are so many of them and so many topics that we obviously can't cover everything. So there is another very important source, which is the extremely detailed synthesis and comprehensive expert reports. What I call a synthesis report of expertise is, for instance, the IPCC report on climate, which is authoritative. You have thousands of researchers identifying which articles match a particular subject and what notable advancements have been made, where have uncertainties decreased, what are the new important pieces of additional information, etc. So the compilations of research work at both the national and international level provide an extensive and comprehensive research base, a knowledge base that allows us to move forward and see what the trends are. There are many, and I will present several examples of them to illustrate to you during this course. And then, to avoid staying too textual, I have added here and there a few examples that I find interesting of what I have called breakthrough innovations, but which can be innovations not necessarily at the technological level. They can be cultural, organizational, and technological. What seems important to me is the potential of these new ideas or these new prototypes or these new ways of doing things, the potential whether they are not yet deployed or are in the process of being deployed or experimented with. So I will systematically and clearly demonstrate it when it is necessary, because there is a distinction in degree between whether it's a theoretical work, a research article, knowledge synthesized by researchers and experts, or an experiment. Here you have some of the reports that I have used as a basis to present the extensive range of possible solutions available in the reports. Here, the non-exhaustive ones. Very quickly, there is the report on the feasibility of the transformation from the Stockholm Resilience Center. The Stockholm Resilience Center is where Johan Rockström worked a few years ago. The World Happiness Report, which is a comprehensive and detailed study, a kind of major report that is published annually on the state of happiness and well-being of countries around the world, providing valuable insights and data. The comprehensive and detailed report by the World Resource Institute, which is an American think tank on how to create sustainable food systems, was led by Tim Searchinger, who is a highly regarded specialist in the field of sustainable food systems and agricultural practices. The UNESCO report that has just been published on new forms of education and how we should transform education for a sustainable world. And then probably the two best known, the IPBES, which is the IPCC of biodiversity, and the IPCC itself. So the climate and biodiversity are two in-depth reports written by thousands of researchers who work collaboratively together to see what the state of the art is, the problem, and the possible solutions. So now that we've said that, it remains to essentially and fundamentally synthesize the four main ideas that I will try to develop in the upcoming and future courses. The first thing is, if we want to transform the world we live in and set ourselves on a more sustainable path, we need to change our objective. It's clear that having economic growth as the only goal without really knowing why is not fundamentally going to help us. We need to build new development indicators that are emancipatory, regenerative, and inclusive. And this is something I will elaborate on in the upcoming video. The three other systemic levers are obviously transforming the economy, encouraging sobriety and circularity, ensuring exponential growth of decarbonized energies if we want to stay below 2 degrees, let alone below 1.5 degrees Celsius, and then massively supporting innovation, because as we will see, even though a lot has been done, we are not entirely out of the woods yet. For the biosphere, we need to massively accelerate the protection of ecosystems. We will see the numbers. The transformation of agri-food systems and the restoration of degraded areas require a complete overhaul and transformation of the entire system. And all this will not be possible without a cultural transformation, for which education is indeed a very good vector, even if it is not the only one.
And so what I tried to synthesize from a phrase we use a lot at the Learning Planet Institute is that we need to learn to take care of ourselves, others, and the planet. This brings us to the different upcoming chapters.
In the first part, we will focus on new indicators and new goals of overall prosperity. How are we going to reconcile growth and prosperity in our society? In a second series of videos, we will look at how to stabilize the climate, particularly by changing the energy system. But not only that, there are other components we will see in other videos. The next one will be on the biosphere and its regeneration. What does this imply for transforming agricultural systems? So we will see how to feed humanity. And then there will be a video on the reorganization and transformation of human metabolism. That is, how we need to reinvent and reorganize our spaces in various ways, reorganize our cities, our industrial systems, and thus reinvent our ways of production in different aspects. And then the last two videos will be more focused on cultural changes. The first on the evolution of our societies, what is already in progress and what we can expect in the coming years. And finally, the last part will be dedicated to the transformation of education that is necessary to successfully carry out all these projects. Thank you, and see you soon.